Good morning and a very warm welcome. Thank you for joining us live for this another exciting episode of Open IIoT webinar series. So my name is Yusuf Salim and I will be your host for today's program presented by Nick Psahoulias of BECKHOFF Automation on exploring supply chain options and how IIoT can help. So before I hand over to this young man, a little intro on who he is. So Nick Psahoulias has been with the BECKHOFF Automation for over 13 years, joined as a national sales manager and transitioned to the role of managing director in 2018. Since then, he has helped the organization to grow from strength to strength, and he is very passionate about automation technology, in particular IIoT, which stands for Industrial Internet of Things, and how these technologies are impacting our lives for good. So before I hand over my to Nick, a quick rundown on how this will roll out. So Nick will have his presentation at 10:05, and which will go for about 15 minutes. Then we will have a Q&A session at 10:20, and then we will see you off at 10:30. Okay, and some housekeeping rules. As I can see, there's a lot of people are here now. So some housekeeping rules. Please keep your cameras and mics off all the time. And if you need to make a comment or if you have a question during the presentation, please only use the chat box area. Over to you, Nick.
Alrighty, thank you very much. Good morning all, and welcome to the third session of Open IIoT seminar series. Today's session is about securing your supply chain. The purpose is to highlight the need for collaborative supply chains, which basically means gathering and sharing data. The process of this presentation is to introduce the small steps necessary and the facts that you may already have this data at hand. You just need to understand how to utilize it. I guess the payoff is that you will feel more comfortable undertaking some of this IoT at your facility. And you will see the benefits in time and money, which are the two main indicators for business, I guess. So some facts about supply chain challenges. Currently, 9 in 10 businesses are facing supply chain challenges, which basically means pretty much all of us. And now everything is online. Everything we do now is online, our buying habits, everything, and manufacturing and fulfillment complexities will continue to grow. And what we're talking about is more products being bought online, more distribution channels required, supply chains will become more complex. And let's not forget the main objective is focusing on our customers. Customers expect more from us now. For example, Uber can tell me where my ride is and what the ETA will be with notifications, yet a major supplier or distributor like Australia Post is having difficulties telling me in which state my parcel is in. So we have these world-leading examples that we should be following in our manufacturing processes, I guess, supply chain processes. And the issues that are most contributing to a company's complexity include the integration and ensuring software, machinery and technologies all work together in the entire logistics ecosystem, which meet and exceed customer expectations for speed, cost and adaptability. And more businesses are paying attention to these supply chain headaches now. We need to balance the expectations and costs, obviously. The good thing is that 2/3 of senior leaders believe that supply chains are mission critical for their company's success, and getting these leaders to understand this is the most important step to gaining support for upgrading our warehouses and end-of-line technology. But to overcome these challenges, there's investment needed. investment in time, and investment in things like software, automation, voice and vision interfaces, robotics, and the overall integration of all of it to streamline the complexities of the supply chain. I mean, just look at the Open IoT group. You've got BECKHOFF, Nord, SMC, ZI Argus, and BECKHOFF. And these are the type of companies that are here to help you through your journey. All right, let's take into consideration a simplified supply chain. This one here is just, making bread and getting it to the retailer. You've got, the raw ingredients, or, the primary produce from the agriculture. You've got the milling, the processing of the grain, the baking, the distribution centers, and finally going to selling at retailers. Each one of these has their internal demands and external factors like freight and logistics and everything else. But is it really so simple? We're doing the supply chain an injustice because it's got a secondary ecosystem which then feeds back onto itself, has inherent delays, and also has waste. So it's not linear. And in reality, there are multiple suppliers to manufacture any product, in this case bread, more than what is possibly showed here. And each one has a role, whether it be a minor role or a major role. And without a reliable supply and distribution model, I mean, the whole ecosystem becomes quite unstable. But okay, here is a still simplified supply chain of two bakeries, each with their own suppliers and their own distribution centres, which may belong to two different supermarket chains. So let's call them Coles and Woolworths. And as we know, there are a dozen of bakeries and dozen distribution centres per state for each supermarket. So it actually gets quite complex. So even though we're trying to illustrate something very complex, I don't think we should be calling it a supply chain. I would say it's more like a supply mesh. In a chain, if one link breaks, then there's discontinuity. But if we look at it more like a mesh, if one link breaks, then the whole system can still overcome the problem. And as manufacturers and suppliers and consumers, we each have a role in providing strength to the mesh, and our strength in this case is data. We can use industrial Internet of Things to make these links talk to each other and really connect suppliers to manufacturers, to retailers, and ultimately to consumers. I mean, what live data is available to a bakery? We've got our supplier data. We've got time to deliver raw ingredients. We've got the humidity of products arriving, the temperature of sensitive products, for instance, like yeast, which is unviable after a certain temperature. We've got local data, which we're more familiar with. We've got machine availability and uptime estimates. We've got our natural resources like electricity, gas, water. We've got the temperatures of the ovens, the vibrations of the rollers. We've got the current draws of the machine. We've got preventative measures that can be done based on this. We've got environmental conditions like the daily temperature, whether it's raining. And we've even got outliers like, is it school holidays that make impact on our production line? It's amazing what you can correlate that doesn't sit on a machine, but actually outside of it. I mean, there's even studies done on, the release of Nicolas Cage movies versus the economic downfall of smaller countries. But now we're really pulling it on that bow. And of course, we've got the consumer data. We've got live sales of products that could determine the next baking run, when unique upticks or trends or panic buying, which we've seen of late, that if we know that a particular product is running off the shelf at 9 a.m. when the supermarket opens, we don't need for end of day collated orders to come through to be prepared for the next run. So also having this feedback from the supermarkets back to the manufacturers allows us to be more preemptive and make decisions based on real information rather than end of day information. So if we were to highlight just these small selections of what can be captured by industrial Internet of Things, and then the technology ensuing it is literally everything. We need to collect all this data and compare it against each other to make more informed decisions. I mean, what are these technologies? If we can just break it down. Well, simply they are the intelligent side of manufacturing, which you're probably already doing this. If we were to look internally to start with at the absolute basics, every machine made in the past 20 years has some semblance of intelligence, and can be used directly or indirectly with supervisory control and analysis systems, either on premises or in the cloud. That's an individual choice. At the higher level, we've got existing machines, and when we're designing new machines, of course, we want to have them more intelligent, but they don't necessarily have to be that way to get started. At the machine level, modern machines use automation controllers that generally have IoT technology built into it, but there's also legacy controllers or other automation equipment out there that may not. For these instances, we would use things like edge devices to convert these legacy signals like Profibus or DeviceNet and channel these to an offsite server or a on-premises server, doesn't matter, using more modern protocols. I mean, the objective is to obtain as much information as possible and then use this data to then educate decisions based on learned events. We have this data, we just need to analyze it, map it, display it, and then predict future requirements based on these learned algorithms. And with enough data from many production lines, definitely trends can be observed. And it's all about monitoring, preventing, and preempting what will happen and what is needed. So some questions that we have in the real world, questions that we've heard, are things like, some days the batter takes longer to rise. Well, that might be from an experienced operator, but if we actually looked at environmental factors, you might say, well, in the middle of winter in Tasmania, the facility is significantly colder, which makes the batter rise slower. But in the middle of summer in Brisbane, the humidity and temperature makes it rise faster. So knowing the environmental factors of the next day, you can make tweaks to the production run of today, or of tomorrow, sorry. And other questions like, the furnace temperature is hotter in the mornings, and I don't know why. Well, sometimes we need to look outside of our factory and see the natural resources that are available in the area. In the morning, the furnace might be hotter because in the afternoon, the next factory uses their furnaces to power their ovens, which starves the normal supply to the area. So it might be a case of actually monitoring the gas flow into the building to then say, well, we need to either install a secondary pipe or get a bigger supply or whatever it is, or adjust our production schedule so we don't then have these problems. So again, it's also looking at what's happening internally and comparing it to externally. Another thing that you might hear is, we bought 3 production lines at the same time from the same manufacturer, but production line 3 always breaks down. We don't know why. Well, we need to compare the production schedule, what products are going down production line 3 versus compared 1 and 2, for instance. Maybe production line 3 gets all the heavy boxes. Maybe it has 25% greater uptime. Maybe it's different operators who treat it differently. It's only through these comparisons and the collection of data that you can then really start to see these trends. Or another one, this is the last one, might be, my temps slow down in the afternoon. So, it might be, someone might consider that a mechanical problem, but it actually might be that the air pressure in the facility is finite, yet the afternoon shifts decide to blow down their area using air brooms rather than normal sweepers, which then the production facility suffers or slows down. And then, in worst case, we've had one facility manager install a $500,000 compressor and new air storage unit, thinking that that they needed more air, but it was actually the way the air was being used that was the issue, not the volume and available air to the site. So what I'm saying is, in general, we need to capture the data, compare it against other occurrences, multiple occurrences, which happen at the same time or precede it. So these are just some things we come across. So, I mean, now what? I have the data. How do I use it? We need to start small, firstly. We need to gain the information that's readily available to us, and from a machine or a production line that we think we know well. If we understand the data that it's given and then we utilize this to get a deeper understanding of the machine, then we can really understand, well, we can really compare what we knew versus what the data is showing us. We can also compare this information against what was usually done by hunch or only through an experienced operator. The operator might say something like, this part usually fails once a month just after this bearing starts to squeak and then that wheel stops. So if we can see that just leading to an event like this, there was excess current drawn on a motor or excess vibration on a bearing or air supply was staved or whatever it was, we can then start to correlate previous events that preceded a breakdown, for instance. And then we can start incrementally adding more information. With more information gives us more insight. And ultimately, this is what we're trying to do, is understand our processes better, to become a better link in the supply mesh. And then once you know one machine, then add a second machine or a second line, then scale up and repeat. And compare these machines versus the environmental factors, the compressors, the motors, the air valves, the vibrations, and gain comparable insights. Of course, this is done, there's really smart algorithms, there's already software packages that will do this for you, that will help you get there. It's not something that you just get all this raw data on an Excel sheet and then you don't know where to start. I guess at the end of the day, what I'm saying is that smart devices can help us make smart choices. And an IoT-based platform is a great investment for any size company, large or small, as long as you have a clear objective of what you want to accomplish at the end of it. Also, you need to consult a skilled group for advice, preferably at the design and the development stage. All of us here, BECKHOFF, Nord, SMC, ZI Argus, and BECKHOFF, we're here to help you. And importantly, make sure that your IT solution meets the supply chain with modern technology trends. Ultimately, it's about gaining knowledge, sharing this in the mesh, and then saving time and money, or gaining profit. And ultimately, we're all in business to make money, to stay in business. If I can give you some examples of larger companies that have done this, we've got some global brands that were at the frontier of the Internet of Things and in supply chain. You've got Amazon, which used connected robots for warehouse management. It picked all the parts using QR codes, identified all the parcels, and then passed them on to the human workforce to be more productive and also have less workplace injuries. And they allowed people to focus on tasks like packing or wrapping or inventory management and better utilization of human resources. You've got Volvo, who used a cloud-based system to monitor every part coming in and out of their plant in order to manufacture cars or deliver cars. And especially in just-in-time planning, their suppliers' data to them was just as important as their own. And Maersk, the Danish shipping company, uses remote container management systems, and it monitors the temperature and humidity of the goods inside the containers, which then reduces food spoilage and reduces weight. I mean, they even monitor the sea conditions to improve their planning and their routing of ships. So I reiterate, start with what you know. It's that simple. At the end, I mean, this was a very quick overview. We're here to help you. Below are the brands you can trust. You don't have to do this alone. From the field to the cloud, these brands here can help you get there. And that brings me to the end. I feel like I was on time.
I think you were on time. So yeah, thank you very much, Nick, for such an insightful presentation on how the use of Open IIoT or the IIoT platform can bring benefits to the supply chain management and how one can gain a competitive advantage through a very scalable supply chain. So thank you very much for the presentation. So I will open the platform for any questions the audience may have. So again, you can use the chat box area for your questions, or if you feel comfortable asking it live, please unmute yourself and ask Nick directly. All right, there's one question which says, "Hi Nick, great presentation. Quick question. How would someone start implementing if they don't have IT skills on site?"
A great question there, thank you. Plain and simple, that you need to surround yourself with people who do have the skill set. Either you can train yourself to start with something small, a small project, and to get greater experience, or consult like the Open IoT group, who can then help you along your journey. No man is an island, so don't expect to try to do everything yourself. It is a vast amount of options available to you, but definitely having, if you have the capacity to have in-house people, that's great. If not, consult specialists like ourselves. But again, I really have to iterate, start with a really simple project and really appreciate what you can learn from just something simple. And then it's like anything, you start with, if you started using Photoshop for the first time, you would start with a very simple drawing, and then within a year, you're very proficient. It's like learning anything new.
All right, so I think that is it. I think there are a couple of comments there saying thank you for the presentation. Appreciate the information. So yeah, thank you very much.
Pleasure. Thank you very much. Thank you, everybody, and I wish you a lovely day.
All right, thank you once again, everyone, and thank you, Nick, for the beautiful presentation. And don't forget, we have our fourth episode of this Open IIoT seminar happening on 1st of October. It will be presented by Joseph Chi from SMC Corporation on creating flexibility in your manufacturing, tips on upscaling or downscaling production after COVID-19. So please join us again in a couple of weeks' time, and we look forward to seeing you again. Have a great day. See you all.